Hey guys, how are we doing? How are we doing? Let me see your faces. Let me see your beautiful faces. I cannot wait till next Monday. What happens next Monday? What happens next Monday? What happens next Monday?
In person.
You're here with me. You're here with me. It's going to be so much easier. It's going to be so much easier. All right. You had what due last Friday? You had what due last Friday? WebAssign. WebAssign homework number 1. Guess what's going to be due this Friday?
WebAssign.
WebAssign homework number 2. WebAssign homework number 2. Now, is that your only homework?
No.
No, you have your textbook homework. Now, where can you find your textbook homework?
In the announcement that you sent out.
Yeah, in the announcement, and I'll keep adding to that. I'll keep adding to that announcement. It won't send you another announcement, so you'll just have to keep going back to that announcement. Did you guys see I also put up a video from last time? Do you see how I also put up a video from last time? So I'm going to keep doing that until you get here. I'm going to keep doing that until you're with me. Because Zoom's just too blurry. Zoom's just too blurry. Next Wednesday, will you be here or on Zoom? No, next Wednesday. Will you be here?
Oh, yeah.
Okay, next Wednesday you're going to have your first quiz. Next Wednesday you're going to have your first quiz. It's going to be on the homework from section 12.1 and 12.2. From the homework in section 12.1 and 12.2. That is in that announcement. That is in that announcement. Dr. Warren, will it come directly from the homework? Yes, it will come directly from the homework. So if you do your homework, you have the, help me out. If you do your homework, you have the quiz. Okay, will the WebAssign this Friday come directly from that same homework? Oh yes, it will. So if you do that homework, you know how to do the So we're learning a key. A key is to to be successful in this class, you should do your homework. Okay, good. Stand up. I can tell you already need this. Stand up. Stretch. Zach, I've got that same shirt. Okay, sit back down. Spring football is coming to JMU, spring football. Oh my gosh, Tom Brady. You just can't say enough about Tom Brady. Okay, I hate Tom Brady, but I mean, the guy's unbelievable. Okay, last time we started learning about how to plot in three-dimensional space. How many people like they're making progress? How many people feel like they're making progress as far as X, Y, Z? So if I talk about X equals 4 in three-dimensional space, all the points that satisfy X equals 4, what are you visualizing right now? What are you visualizing? What's coming into your head? When I say X equals 4 in three-dimensional space, what are you visualizing?
A wall.
A wall, a plane. Now, if I'm at the X, Y, Z, if my feet are at the origin, and my Z-axis is going up, my X-axis is going out, and my Y-axis is going that way, if I wanted to run into that plane, X equals 4, what would I do? If I wanted to run into that plane, what would I do?
Walk straight.
Just walk ahead, 4. Now, if I said Z equals -2, what are you visualizing? If I say Z equals -2, what are you visualizing?
A floor.
A floor. Now, would that floor be under or above the floor Z equals 0? Would that be under or above the floor Z equals 0?
Under.
Under. How about Y equals 2? How about Y equals 2? All the points that satisfy Y equals 2. A wall, but to hit that wall, I would go
To your left.
this way and then march 2, and then I'd run into that wall. Plotting in 3 dimensions is a bit of work. So what I've put up, what I want you to do right now is I want you guys to go to the announcements. And in one of the announcements, there's something called, I don't know what I've named it, something lame, probably called Easy Web Plotter, or something lame like that. So go find that in announcements and click on that hyperlink. How many people are seeing it in announcements? How How many people have clicked on it already? How many people have clicked on it? How many people see that surface there? How many people that see that surface? Okay, now let's look at that surface. That surface is equal to what? That surface is what? What is that? What is that? Read that. What is that surface? What is it?
Z equals
Z equals?
xy divided by e to the x squared plus y squared.
Yeah, okay, now you're looking at that. Do you guys think you could plot that? Do you think that would have come into your head? If I said, oh, guess what? Z equals that. E divided by that. You'd be like, no, I can't plot that. But can this thing plot it? Can this thing plot it? Okay, grab that plot and start moving it around. Grab that plot and start moving it around. See that you have control over it. You can look on all sides of it. You can look above it. You can look below it, and so on. Now, I'm going to join you at the front of the room. I'm going to join you at the front of the room. You guys don't realize this right now, but I teach at the back of the room. I'm teaching at the back of the room. The screen is at the front of the room because I see you on a grid. I don't want to turn my camera because it's really hard wide angle to get this, but I can turn it around. Oh, I don't care. Screw it. Do you guys see you there? Do you guys see you there? See, that's you. You guys are in the grid right there. Okay, and I'm teaching at the back of the room. Now, just screwed up my camera for the rest of the class. Oh well, we'll work it out. Try that. Okay, we'll call that good. Okay, now I'm going to go to the front of the room, and I'm going to share my screen. Okay, can you guys see this? Are we seeing the same picture now? You and I, are we seeing the same picture?
Yes.
Okay, so what we're going to do is we're just going to get rid of this. So just go up, you see that little X there? Just click that X and that plot will vanish. Just click that X and that plot will vanish. Okay, I guess maybe the first thing that I'll show you is if I click on that, do you see that blue one there? Click on that. This allows you to set whatever you want. So let's make this like X equals like -4, 4, and we'll make all of these -4 and 4. Oh, not 24. And then we'll just hit graph. And do you see how that changed? Do you see over here how that changed our axes? Do you see how that changed our axes over there? Okay, so now, there's a drop-down menu. We're going to add a graph. Let's make this go away. Let's make that go away. Okay, and the thing that we're going to be using for a little bit is this thing called implicit surface. So we're just going to go to our drop-down menu and click implicit surface. Okay, now, this is x squared plus y squared plus z squared equals 2. Let's change this to a plus. So write x squared plus y squared plus z squared, and let's make it equal to 4. Okay, now I'm going to come back up to the camera. I'm going to come back up to the camera so you can hear me better. Okay, you've done your homework. You've done your homework in 12.1, or you at least did enough to do the WebAssign. What shape will x squared plus y squared plus z squared equals 4 create?
Sphere.
A sphere of radius what? A sphere of radius what?
4.
2.
Of 2. A sphere of radius 2. So now I'm going to go back here, and you can see there's a box. There's a box here where I can click this that will add that graph. Now you guys see that sphere. Can you see that sphere? So let's move this sphere around, and we can see here that we can see this sphere in any direction we want. Now let's play with this. Let's go back to this equation and just change one of the pluses to a minus and see if it makes a difference. Are we looking at a completely different shape, guys? Are we looking at a completely different shape now? Let's move this around. This point right here is actually called a saddle point. This point up here is called a saddle point. Do you see why they call it a saddle point?
You see why they call it a saddle point if you're looking at that there. If you were riding a horse, wouldn't you rather be sitting here than up here? Okay, we call this a saddle point. But let's not get rid of, let's just get rid of this. This is too complicated. Let's make another one that you guys can understand. Let's go down and do an implicit plot. And let's do x equals 3. Okay, guys, now when we plot this, what should it look like? When we plot this, what should it look like? I heard one person. What should it look like? A plane. Do you see our plane there? Do you see our plane? Do you see that plane, x equals 3, which is kind of what you guys were visualizing. Now let's add another surface. Let's do z equals -2. And add that, and then let's add this back in. Oh, not that one. Let's do x equals 3. And our two planes intersect in a what, guys? Our two planes intersect in a what? Do you see that? Our two planes intersect in a what?
Line.
A line. Okay, so I'm going to stop sharing. I'm going to stop sharing. Now, while you're not allowed to use that, you're not allowed to use that package on a quiz or a test, you are allowed to use it on your homework. Could this help you? Could this help you with your homework when you're trying to figure out plots? Now, chances are, I'm not going to make you do a ton of graphing in this class. It's because it just gets a little complicated. Most of the time on tests or quizzes, you're going to be matching graphs to equations. What did I just say?
Matching graphs.
You're going to be matching graphs to equations. You're going to be matching graphs to equations. But I do want you to understand how to plot certain things. Okay, so one of the things I want you to do is to understand why the equation of a sphere is the equation of the sphere. This right here is our what? This right here, I'm pointing to what? Can you see that? I'm pointing to what? What am I pointing to?
You're not on the camera. You're on camera.
Oh. I'm going to regret this. Can you guys see this now? What's that? I know I'm not in the camera. What is that? Read that. The distance formula. This is the distance between any 2 points in three-dimensional space. True or false? True or false? How did we derive that formula? What did we use to derive that formula, guys? The Pythagorean theorem. The Pythagorean theorem twice. So if I have 2 points, one is x1, y1, z1. The other is what?
x2, y2, z2.
And I want to find the distance between those 2 points. Well, it's just x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, and I take the square root. Is that pretty nice compared to the distance formula in 1 dimension, or in 2 dimensions? Isn't that kind of the same kind of thing in how nice that is, how nicely that extends? Now, let's read this. Can you guys see this? S
This is
equals the
order triplet x, y, z.
the set. Say that. Say that. Say that.
Set.
The set of order triples
X, Y, Z.
x, y, z such that
Square root of x minus 2 squared plus 1 minus 3 squared
Plus Z minus 4
squared equals 24.
equals 25 is true. That's what we're trying to do. Find all the order triples such that that's true. Draw yourself an x, y, z. Draw yourself an x, y, z. And then you can see what's one of the points. If you were using the distance formula there, what's one of the points? The one that you could probably make the most sense of. What's one of the points you're using in that distance formula? Okay, and that would be 2, 3, 4. So do your best to plot 2, 3, 4. And your x, y, z, try to your best to plot the point 2, 3, 4. Okay, we're plotting the point 2, 3, 4. What does the 2 tell you to do? What does the 2 tell you to do, guys? What does the 2 tell you to do?
Go 2 on the x-axis.
Go 2 on the x-axis. Then we would go 4 on the z-axis. And then we go 3 on the y-axis. So if I just kind of go straight over like this, I can kind of visualize that point right there as being my point 2, 3, 4. Are you guys with me? Are you with me? Are you with me? How many people are with me? Think about how much we've learned already. Think about how much we've learned already in this class. Now I come over here. I want all the points that satisfy this equation, which means I want all the points whose distance from 2, 3, 4 is what? I want all the points, well, let's not make that 25, that'd be too big to draw. Let's make it 5. Let's make it 5. I want all the points, all the points whose distance from 2, 3, 4 is 5. So if I go 5 this direction, I go up 5, would that point be an S? If I went straight up from that corner, would that point be an S? Would that point be an S? And if I went straight over that direction, would that point also be an S? And I could keep doing that, moving in all directions possible. And if I do that, do you see the shape that you're going to get as a sphere? Do you guys see that you're going to get a shape of a sphere of radius 5? Okay. Okay, guys. Now, the formula that I want you to write down for a sphere, I don't want you to use the square root. I don't want you to use the square root. Let's square both sides. If I squared both sides, I would get rid of the square root, and I would have x minus 2 squared plus y minus 3 squared plus z minus 4 squared equals 5 squared, which is equal to 25. Okay, I'm going to check you. I'm going to check your work here in just a moment. I want you to write down, focus, the equation, the general form for the equation of a sphere in the XYZ coordinate system who has a center at the point ABC. The center is the point ABC. And its radius is r. Its radius is r. Write down the equation of a sphere of center ABC, whose radius is r, and put a box around it, because that's a flashcard. I want you to turn that into a flashcard. Okay, go to grid view, go to grid view, go to grid view, go to grid view, go to grid view. Look at yourselves, look at yourself. Go to grid view. Okay, hold up what you have. I want to see your equations. I want to see your equations. What do you guys have? What do you have as your equations? Pierre, I'm loving it. I'm loving it. Yeah, Joe. Yeah, Joe. Okay, good, Zach. Good, 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 good. Excellent, 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 excellent. Okay, excellent. Excellent. Okay, you guys have it. You guys have it. Okay, so now I'm gonna write down the equation of a sphere, and you guys are gonna tell me where the center is and what's the radius. Are you ready? Are you ready? Okay. All the points that satisfy x plus 3 squared plus y minus 2 squared plus z plus 8 squared equals 49 would make the shape of a what in three-dimensional space? All the points that satisfy would make the shape of a what?
Sphere.
Sphere. Find the center and the radius of that sphere. Find the center and the radius of that sphere. Okay, what do you guys have? What's the center? What's the center? What's the center? What's the center? What's the center?
-5 to -8.
-5. The center is negative, that's not a 5. -3. I know you can't see. 2 and -8. How many people had that? How many people had that or something like that? What is the radius of that sphere? What is the radius of that sphere?
7.
The radius of that sphere is 7. Okay, now let's suppose that I said, nah, I lied. No, it's not 49. It's not 49. It's 31. It's equal to 31. What's the shape? What's the shape? What's the shape?
Sphere.
What's the radius of that sphere?
Square root of 31.
The square root of 31. Now let's look at this equation. We've got x squared plus 6x plus y minus 2 squared plus z minus 3 squared equals 25. Does this look different?
Yes.
Yeah, we've got this linear term that wasn't there before. But guys, this is a sphere also. You're like, no, it's not, Dr. Warren. This is a sphere also. Now I'm going to show you guys how to put this into a form where you can tell the center. What's two of the coordinates? What's two of the coordinates of the center? What's two coordinates? What can you tell immediately is two coordinates?
2, 3, 2.
2 and 3. That the y coordinate's 2 and the z coordinate's 3. How do we find the x coordinate?
Complete the square.
Complete the square. And so what I want to do is go back for some of you and talk about completing the square. Now let's ignore this for a moment and let's just go back to here. What do I have here? What's the expression I have? What is this?
Quadratic.
A quadratic. X squared plus 6x plus 1. Now, can you factor that? Can you factor x squared plus 6x plus 1? Hopefully, you're making all of your teachers proud by saying no. But now, let me show you guys visually how completing the square works. If I think it's called completing the what, guys? What is it called again? Completing the what? Square, okay? But kids often come to me not understanding why it's called completing the square. So if I think about x, I can think about having a square where one side is x and the other side is x. Then the area would be, well, you guys should know this, you're in Calc 3. X squared. So that would be like this shape right here. Now I can take some other length as 1, just call it 1, and this would be x, And what would the area of this rectangle be? What would the area of this rectangle be?
X.
X. So you can see here, if I look at this, I've got x squared, but now I've got 6 rectangles. 1, 2, 3, 4, 5, 6, where all of them has width 1 and length x. And so if I look at this, this would be like x squared plus 6x. And since we made this 1, 1 times 1 would be 1. So this is a visual description of x squared plus 6x plus 1. Now imagine you give this to your little brother. You give your little brother and sister these shapes. Give them this, these 6 rectangles, and this 1, and you say, do the very best you can at making a square. You've got to take these shapes and create the biggest possible square, or something that would look like a square. What would he do with these guys? What would he do with these guys first? What would you do with them? You got these 6 x's and you got this x squared. What would you do if you were trying to make a square? You'd start putting together. You'd probably stare at it a while. And you'd be like, okay, well, we've got this. Now let's take 3 of those. Let's take 3 of these and put them here. And then what would you do? If you take 3 of those, then what would you do?
Put 3 on the other side.
Put 3 on the other side. But now suddenly you're missing these guys. You're missing these guys. You've got this. This is good. 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 But how many of these do you have? How many of these do you have? How many of these do you have?
1.
1. How many more would you need to complete the square? How many more would you need to complete the square?
8.
8. And so you could add in 8. But then you need to realize that you needed to subtract 8 to keep everything balanced. So you could think of this as being x squared plus 6x plus the 9 I needed to complete the square minus 8, which gets me back to my 1. And this is the visual idea of completing the square. Notice when we do this, we get x plus 3 times x plus 3 minus 8, or x plus 3 squared minus 8. Now notice what we did is we took the 6 x's and we cut them in half. We took the 6 x's and we cut them in half. And then we've got to get our 9. We've got to fill in these. We've got to fill in those and balance things out. So if I would look at this, this would be the same thing as x plus 3 squared, then minus 8, plus my y minus 2 squared, plus z minus 3 squared equals 25. You're like, Dr. Warren, that still doesn't look like a sphere. That still doesn't look like a sphere. But if I take the 8 to the other side, now suddenly it looks like a sphere. Now suddenly it looks like a sphere. What's the center of the sphere? What's the center of the sphere? What's the center of the sphere, guys?
Negative 3, 2, negative 3.
It's negative 2, 3, and then 3. That would be a negative. I know it's hard to see. What's the radius of the sphere? What's the radius of the sphere? The square root of 33. The square root of 33. Does this make sense, guys? Does this make sense? Okay, now I'm going to give you a problem. And I'm going to have you guys do the same thing. Okay, are you ready? I'm going to give you a problem. In fact, I did give you a problem. It's from your textbook. You're now doing your homework. Okay, this is what you've got. Are you ready? Write this down. X squared plus y squared plus z squared minus 2x minus 4y
plus 8z equals 15. I'll read it off again. X squared plus y squared plus z squared minus 2x minus 4y plus 8z equals 15. Try to find the equation of the sphere. Try to find the center and the radius of that sphere. Zach, I can't see your face. Zach, I need to see your face. Thanks, Zach. Okay, guys, you're going to go to breakout rooms. I know you love this. You're going to go to breakout rooms and you're going to talk to each other. What did I just say? 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 And what else did I say? What else did I say?
And talk to each other.
Okay, so that means like your mouths move and you communicate with each other. So you're going to breakout rooms. You're going to breakout rooms. Okay, you guys get to pick. How many people do you want in each room? How many people do you want in each room? What do you guys pick? Whatever you want. First number right here, that's what I'm choosing. You say 1, I'm going to be pissed. Okay, 3, I see that, Sam. You didn't say anything, but I like it. Okay, 3, so you picked 3. Here you go. 3, 2, 1. Okay, let me get. There we go. There we go. There we go. Okay, now this problem sucks royally because you don't only have to complete the square in x, but you also have to complete the square in
Y and Z.
y and z. Okay, so let's come over here and look here. The key is dividing by 2. If you take -2 and cut it in half, you get -1, and you square that. That tells you what you need to add here, playing essentially the game we did before. I would need to add a 1 to complete the square there. I would need to add a 1 to complete the square there. To do that, I would want to add a 1 on the other side to keep my equation balanced. How many people are with me? How many people got to that? Okay. If I do the same thing, if I take -4, cut it in half, I get -2, and I square that, I get 4. That's what I'm going to need to complete the square there. I balance it out since I added 4 there, I add it to the other side. Same thing here, -8 divided by 2 is -4. -4 squared is 16. I add 16. I add 16. Did anybody get to that point? Was there anybody that made it to that point? Anybody make it to that point? Okay. Now this is nice because that factors into what, guys? That factors into what?
X minus 1 squared.
X minus 1 squared. This factors into what? This factors into what?
Y minus
Minus
2
2 squared.
This factors into what? This factors into what?
Z plus
Z
4
plus
plus
3 squared.
And then if I add 15, 16, 20, I get a 36. Did anybody reach that equation? Did anybody reach that equation? And so you got a circle of radius what? You got a circle of radius what?
6.
6. Where's the center? Where's the center? Where's the center of this circle?
1, 2,
-4.
1, 2, 1, 2, 4. Did I say plus? I'm a moron. I wrote down the wrong one. This is plus, so that would be plus. Okay. Does this make sense, guys? Is this making sense? Does this make sense? Because these problems seem far harder. And people are like, this is so hard. But I'm like, nah, when you really tear it apart, it's not so bad. It's not so bad. Okay, stand up, stand up, stand up. I know you need to stand up. You know you need to stand up. Stretch, stretch. You got a cat. Nice, nice one. Okay, sit back down, sit back down, sit back down. Okay, okay, okay. What can I make you do? How do I get you to focus? How can I get you to focus? Let me tell you a story about my brother Doug. Did I ever tell you about Doug? Did I ever tell you about my brother Doug? Have I said anything about my brother Doug? Okay, so let me just tell you, okay? Me and my brother, we had a confrontational relationship growing up. Okay, well, it wasn't confrontational. There were just times where he would drive me crazy. Does anybody have any younger brothers or sisters? Does anybody have any younger brothers or sisters? Okay, my first memory of my brother Doug was this. I was probably 4, because he must have been 2. And my memory was looking at the Christmas tree. Now, as a 4-year-old, a 6-foot Christmas tree is pretty high. It's at least twice, if not 3 times your height. So I'm just looking at the Christmas tree, and the next thing I see is this surreal moment of the tree moving. And I'm just like, the Christmas tree's moving. The Christmas tree's moving. And you think a smart kid would move out of the way. But no. The Christmas tree comes falling towards me and lands like 6 inches from where I'm standing. All the ornaments shatter and go all over the floor. You know, like you think, at that moment I realized, in a trench, you don't want me with you. Okay?
because I froze. In the moment to try to save you and save myself, I froze. I did not move. The next thing I saw was my brother dog laughing at me. The next thing I saw was my brother dog laughing at me. 2 years old, he's pushing the tree towards me to try to kill me, I'm sure. It was to try to kill me. Eliminate the need for this other thing feeding off the mother or the parents. That's what I think was going on. Okay, so now that I've told you about Doug, let's go back, because you often feel like, Dr. Warren, are you sure you're not Doug? Because I feel like that in this class. I feel like you're pushing the Christmas tree towards me. I feel like you're pushing the Christmas tree towards me. Okay, let's go back to Algebra 2. How many people could plot that? How many people could plot that? How many people could plot that? And how many people could plot that? How many people could plot that? How many people could plot that? How many people think they could plot this? How many people think they could plot this? Okay, you said you could plot it. Plot them. Plot on 3 different XYs. Plot those. Okay, they don't have to be real accurate. They don't have to be real accurate. Just some rough sketches. Okay, go to grid view and hold up what you have. Wherever you're at, go to grid view, hold up. I want to see your graphs. I want to see your graphs. You said you could graph these. You said you could graph these. Okay, I'm liking what I'm seeing. I'm like, look around at some of your buddies. Look around at some of the other stuff. Look at what other people have plotted, guys. Look at what other people have plotted. Okay, look at Alex's. Look at Alex's. He's up in the corner for me. He's got a parabola. He's got a parabola opening up. Which one would that be? He's got the parabola opening up. Of those 3, which one would that be?
X squared.
Y equals x squared. He's got a drunk parabola that's fallen over. He's got a drunk parabola that's fallen over. What would that one be? What would that one be?
Y equals x squared.
Okay, yeah, x equals y squared. And then he's got the circle, which we all know what that is. Okay, make me number 1. Make me number 1. You guys did great. You guys did great. Now, let's ask the same question, but now we're talking in 3-dimensional space. Now we're talking in 3-dimensional space. What if I said the same thing? You're looking at x squared plus y squared equals 4, but now you're in 3-dimensional space. You're in your x, y, z space. Plot what that looks like. Plot x squared plus y squared equals 4. All the points that satisfy x squared plus y squared equals 4 and your x, y, z coordinate system. Graph the shape of all the points that satisfy x squared plus y squared equals 4 in your 3-dimensional space. Okay, again, for time, show me what you've got. Go to grid view and hold up what you have. Go to grid view and hold up what you have. Go to grid view and hold up what you have. Yeah, I'm seeing some nice things. Seeing some nice things there. Look at Brianna's. Look at Brianna's. Do you see what Brianna has there? What does she have there? What are you guys seeing there? What do you see in Brianna's? A cylinder. Okay, so make me number 1 again. Make me number 1 again. Now, almost everybody did a great job. Almost everybody did a great job. This would be my z-axis. This is my x-axis. This is my y-axis of drawing this, where they drew the circle down here. True or false? Do all the points in this circle, would they be in S? Dr. Warren, what the hell did you say?
True.
Would all the points on this circle be included in S?
True.
Would they satisfy that x squared plus y squared is equal to 4?
Yes.
Okay, now, take your cape, take out your cape, take out your cape. Some of you guys aren't doing it. Take out your cape, tie on your cape, tie on your cape, tie on your cape, tie on your... Now you are Doctor Strange. Now you are Doctor Strange. Which of the three variables is not in the equation? Which of the three equations, which one's not in the equation? Z. So now you go all Doctor Strange in the Z direction. Because you can take this thing and sweep it up and sweep it down, and they would still be in there. And that's where Brianna's getting her cylinder. That's where she's getting her cylinder. True or false? True or false? Would the points inside the cylinder be an S? Would the points inside the cylinder be an S?
False. False.
So if I wanted to make this a solid piece of steel, if I wanted to talk about all the points that in this solid cylinder, what would I need to change over here? What would I need to change over here if I...
Make it an inequality.
You need to make it a less than or equal to. If you made it a less than or equal to, then you would have your solid cylinder. Is this making sense? Is this making sense? Okay, now for a harder one. Plot this guy. Plot that guy in three-dimensional space. What are all the points in three-dimensional space that satisfies our good friend the parabola, y equals x squared in the plane? Okay, go to grid view and show me your art. Go to grid view and show me your art. I want to see what you have. I want to see what you guys are having there. I want to see what you have. Look around. See what other people are drawing. See what other people are drawing. See what other people are drawing. Nice, 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 guys. I see lots of good stuff. I see lots of good stuff. I'm going to pick out Ryland. I'm going to pick out Ryland here. If you look at Ryland's, do you see how he has that parabola? Look at the parabola down there on the plane. Do you see how it's opening on the y-axis? Do you see how it's opening on the y-axis? And then he's gone totally Doctor Strange in the z direction. Then he's gone totally Doctor Strange in the z direction. Okay. One more. Here we go. Yeah, I want you guys to plot this. I want you to plot x squared, all the points that satisfy x squared plus y squared plus z squared equals 4. Plot all the points that satisfy x squared plus y squared plus z squared equals 4. Okay, for sake of time, what are you guys drawing? What are you drawing there, guys? What are you drawing? What shape are you drawing?
Sphere.
A sphere. Where's the center of your sphere?
0,
0, 0, 0, the origin. What's the radius of your sphere? 2. Excellent. Okay, now you're going to do one of your homework problems. The quiz next Wednesdays on which sections? 12.1 and 12.2. Okay, so this is what they ask. Okay, what I want you to do is draw they don't ask you to draw, but I'm going to ask you to draw. Draw all the points that would satisfy the following inequality. What are all the points, x, y, z, that satisfy that x squared plus z squared is less than or equal to 9? X squared plus z squared is less than or equal to 9. This was the last question. This was the biggest numbered question in the homework. And usually they get harder as you go along. Plot x squared plus z squared is less than or equal to 9. Now you're doing your homework. See, this is where it's so good I can see your faces. I can see you working. I can see you guys working. I can still see you drawing. Okay, for lack of time, go to grid view and hold up what you have. Go to grid view. If this was on the quiz, what shape would you be drawing? What shape would you be drawing? Yeah, look at Zachary. If you look at Zachary's over here, he definitely has a cylinder. How many people had a cylinder? Awesome. But he's also indicated that he's kind of filled it in, that it's a solid cylinder. So just kind of shade it so that it looks like, notice it's opening along the which axis? That cylinder's going up and down the which axis?
Y-axis.
The axis that wasn't there. The Doctor Strange direction. Okay, guys, how many people, is this beginning to make sense? Or are you beginning to visualize a little bit better in three-dimensional space? Okay, you know it's going to get a lot harder. Okay, we're ready to start 12-2, so you better stand up. I am now kicking you out of the helicopter seriously. Zach, I've got that same shirt. I probably said that already once today. I'm so ADD, I forget. And Zachary, I think I have your shirt too. Okay, stretch. Okay, sit down. Okay, put your hands on the space bar. Okay, I want you to tell each other, holy crap. Just say it. Go ahead.
Holy crap.
Okay, so now we're ready to start vector calculus. What are we going to start?
Vector calculus.
Okay, so what do you think that means? It's kind of in the name. What do you think it means?
Using calculus and vectors.
Yeah, using calculus and vectors. Math is what? If you learn nothing else in this class, by the end you better be able to answer this question. Math is proof. That's right. Say that.
Math is proof.
There's nothing more important as far as essential job skill that I can teach you other than making a proof. We prove everything in math. That's what makes it different. It's hard to do that in biology. It's too gross. It's like, ooh, you've got yuck, protoplasma. Okay, in Burris, you guys don't know this. In Burris, the building you're going to be coming to, there's dead bodies in here. There's dead bodies in this building. They're up on the 3rd floor. They have anatomy labs up there with cadavers up on the 3rd floor. They didn't tell me this. I go up to the 3rd floor, and I'm looking at the door and it says no food or drink. And I'm like, that's interesting. Why can't they have food or drink? I haven't seen that. And then I looked in the room and there were people working on dead bodies, moving stuff in. They have 5-gallon buckets, like Home Depot buckets, that they're pouring the leftover body parts into I'm like, I don't think that person realized when they wrote on their license, okay, I'm gonna donate my body to science. I don't think they saw their body going into a Home Depot bucket. I just didn't think they visualized body parts going into, oh, let's throw those intestines into that bucket. And I'm like, no food or drink, who in their right mind would dissect a human being and then eat over top of them at the same time? Okay, but enough of that, okay. Math is proof. How many people have been in physics before? How many people have had an engineering class? A chemistry class? How many people have had a chemistry class? How many times do they write down equations and don't explain why? How many times have you sat and looked at that equation and you've gone, I wonder why that's true. I wonder why that's true. Well, in math, that's what it's all about, explaining why something's true. So the first thing we've got to do is define what it means to be a vector. Guys, this is going to take the rest of the class, just defining our vector space. Are you ready? You guys are just going to be little scribes. You guys are just going to be little scribes. So here we go. Now I've moved my camera. Can you guys see this? Can you see that part of the board?
Yes.
No. Well, remember, you guys said holy crap, so you already know. Okay, so this is my lazy. That's laziness for definition. That's laziness for definition. DEF parentheses N. Okay, that's a V, a funny looking R with a 3. And now I'm going to tell you what that means. This is the definition of our vector space V on the real numbers, our three-dimensional real number space, on R3. Okay, now you read what you say what I just said. You say what I just said.
Definition.
Vector space V
Vector space
on R3.
on R3.
Okay, you're like, Dr. Warren, what the hell is R3? So ask that.
What the hell is R3?
We're just talking about all of our X, Y, Z coordinates. This is an element of. What does that symbol mean? I'm gonna keep saying it over and over. What does that say?
Yellow.
And we say R3. So when we're talking about points, we're really talking about R3. X, Y, Z are all real numbers. X, Y, Z are all real numbers. So like, for example, the point, help me out, read. The point 235 is an element of R3, is an element of R3, because is 2 a real number? Is 2 a real number? Is 2 a real number?
Yes.
Is 3 a real number? Is 3 a real number?
Yes.
And is 5 a real number?
Yes.
Okay, so this is what we're talking about. Like Dr. Warren, we've only written down 2 symbols so far. So let's read it again. Because if we can't read it, we're not going to understand it.
Definition.
Of a vector space V on R3. Okay, I'm gonna help you out. Can you read that? Can you guys read that or not? I don't know how blurry it is. Is the set of triples of the form, okay. Now guys, this is where we're going to define a vector. This is where we're going to define a vector. In most books, a vector is written like this. If you want to talk about a vector A, they make a bold A. So it's bold, like you highlighted it and you hit bold. How many people realize I'm screwed at the chalkboard with this? How many people realize I'm screwed at the chalkboard writing in bold? Okay, now in physics, they often use this where they put an A and they put an arrow over the top of it. Have you seen that notation before? Have you seen that notation? Okay, I'm not using that notation, okay? I'm just going to write a squiggle, and this is like a mathematical way. All of these mean the same way. All of these things. This just means a vector. It's a bold, it's bold. And I can't write bold. And let me just say now, this is going to be a little bit different definition than what you do in physics. Okay. Okay, so let's read again. Let's read again from the very beginning. Help me out.
Definition.
Definition.
Vector space
Vector space V
V.
on.
R3.
Now you're like, I understand these. Go ahead.
Is
The set of ordered
Bold A, we'll just say A, equals. Now notice, these are not these. These are not parentheses. These have points. It's going to be our vector. This is going to be our vector. It looks a lot alike. It looks a lot alike. A1, A2, A3. This is an order. It's all in the word. Read that. Triple. Okay. Now notice, how many things are there? How many things are there? How many things are there?
3.
Does it make sense why it's called triple? Does it make sense why it's called a triple?
Yes.
There's an order to them. It matters where these are at. If you switch them around, there's a different order, so it'd be a different vector. Like, for example, does it make sense that 1, 2, 3 would be different than 3, 2, 1? Does that make sense?
Yes.
They're ordered triples, but the order matters. And I guess I'm writing big so that you guys can. I'm writing big so that you guys can see it in Zoom. Okay, now you guys read that. Read that. I've written it down. I'm hoping now you're beginning to be able to read that. Read what is the English? What is that saying? Such that what? Of the real numbers, are elements of the real numbers. Okay, read that. Read that to me. Read that to me. What is that saying? What does that say?
Subject to an addition defined by.
The subject to an addition defined by. Okay, now I stop. Now I stop for a moment. And now I take a brief historical tangent. I don't know, that sounded smart, but it didn't really sound that smart. Okay, vectors. The idea of vectors. Oftentimes it's not understood. The history of it's not understood. How many people are familiar with the imaginary unit I? How many people are familiar with I? Okay, you go back, I think it's in the SOL. which is an interesting name. When I came from Ohio and they were talking about what test my daughter was going to be taking at the end of the year, how many people were from Virginia? How many people were from Virginia? How many people were from Virginia? They take this test called the SOL, and I'm like, that means something different in Ohio than it means in Virginia. When somebody says you're SOL, okay, that means something else than standard of learning in Ohio. So I thought it was an interesting thing. But if you have I, what did you learn about I when you were in high school? What do you know about the imaginary unit I?
It's the square root of negative 1.
It's the square root of negative 1. All right, I is equal to the square root of negative 1. Or that I squared is
Negative 1.
negative 1. That I squared, the imaginary unit I, is such that I squared is negative 1. And this comes to this thing called the complex numbers. Okay, so say that again. What did I just say? Complex numbers. Complex means complicated? No, it just means more than one part. Like, for example, 2 plus 3i. 2 plus 3i is a complex number. It has a real part, and then it has an imaginary part. How many people have seen these before? How many people have seen these before? And you can do a multiplication. You can have 5 plus 4i times 2 plus 3i. Now here's the thing. Most kids don't realize how cool complex numbers are. And they don't realize that back in the 1800s, there was a geometry associated with complex numbers. They used them to do rotations in the plane. But that's been lost historically. One of the most important things with complex numbers is the idea of being able to rotate objects. Now I've got to ask, is rotation important in engineering? Is being able to rotate stuff important in engineering and science?
Yes.
I mean, let's grab one of these. How many people have one of these? Has anybody lost one of these before? Has anybody lost one of these? Have anybody lost it? What are you so glad there is on somebody else's phone when you've lost your phone?
GPS.
GPS. What does GPS stand for?
Global positioning system.
Global positioning system. How does it work?
Satellites.
Off of satellites. Is it important that we can rotate satellites? I know this is dumb. Is it important that we can rotate satellites?
Yes.
I mean, how does that happen? How do we rotate satellites? Math. It's all math. Okay, you guys are going to take this class called linear algebra. We're using matrices, and it's all about rotating things. Do I have any computer science majors in here? Do I have any computer science? I mean, you talk about rotations all the time. Okay, so, well, Dr. Moore, where's this going? Well, there was a guy by the name of Hamilton that wanted to do the insane. He wanted to, and get this, he wanted to make an algebra for geometry. Say that.
You want to make an
algebra for geometry.
Yeah, he wanted to make an algebra for geometry of three-dimensional space. It sounds insane. Mix algebra and geometry. That's insane. And he wanted to build off the complex numbers. He wanted to come up and extend the idea of a complex number. And he said, well, if I can use something like a plus bi, if I can use something like this real number plus a real number times I, and that describes rotation in my, essentially something like my XY coordinate system in my plane, there has to be a way to extend this to three-dimensional space. And he tried, I think it was probably, if I remember what I read in the book, it was probably like a year and couldn't do it. He thought about it and thought about it. And this was his hang-up. He said, well, if I can use this for a plane, then I should be able to extend it where I add another complex unit, So I squared would be -1, but j squared would also be -1. And it didn't work. He tried and tried and tried and tried to come up using these two complex units, I and now J. And while he was walking to church with his wife, and I guess Hamilton was kind of an alcoholic towards the end of his life. Okay, but he was an alcoholic, but he was walking to church, and supposedly he didn't have a great relationship with his wife either. So he's thinking about something other than his wife, probably was he's walking to church. But as he was crossing the Broom Bridge in Ireland, he had a eureka moment. And he was so afraid that he'd forget it during church that he took his pocket knife out and carved on the bridge his relationship for the quaternions. He realized at that moment he needed 3 complex numbers, not 2. And he wrote them down. And he wrote down the following relationship. Now, of course, that bridge is gone. But the bridge that goes over top of it, they have engraved into that bridge what Hamilton carved for his quaternions. Okay? Here's the thing. The quaternions lived really well for 50 years. And then a guy by the name of Gibbs. Have you ever heard of Gibbs in physics before? Okay? Gibbs came along and essentially wrecked the quaternions. He probably set us back. Gibbs probably set us back 50 years. I really think if people would have just accepted the quaternions and not gone to what we understand vectors as being today, we would be ahead 50 years as far as vector calculus is concerned. It's only really around the late 1990s that people began to realize quaternions are superior. They were superior to vectors because they include it, and they're also superior to matrices when it comes to dealing with rotations. But let me just write down, and then I'm going to let you go, what Hamilton wrote on the bridge. I'm going to write down, and you'll see some similarities to what you maybe already understand. He wrote this down on his bridge. He needed 3 units, so he cleverly called them I, J, and K. He called them I, J, and K. And then he said, just like the complex unit, I squared, I'm writing it down like it'd be written on the bridge. I squared equals J squared equals K squared, which is equal to -1. All of the squares of these numbers are -1. And then he drew this circle going counterclockwise. And he said, I times J, following the circle, I times J is K. But if you reverse it, J times I would be -K. J times I would be -K. And then he went J times K. Now you guys follow the circle. J times K would be, you guys follow the circle. J times K would be I. But if you went the other way, you'd be going against the circle. K times J would be, K times J would be -I. Okay, now you guys are going to help me with the last one. You're going to be helping me with, I've got I times J and I've got J times K. What don't I have yet? I've got I times J and I've got J times K. What don't I have?
K times I.
K times I would be, K times I would be J. But I times K would be, I times K would be -J. Okay, and I'm going to have to let you go. But what Gibbs did is Gibbs ripped apart Hamilton's product. And you'll notice, who's had physics before? Who's had physics before? we haven't talked about this and we're not ready. I cross J is K, but J cross I is negative K. He essentially just took Hamilton's product and tore it apart. We'll pick up with this on when?
Wednesday.
On Wednesday. Thanks for playing with me. How many people are learning? Okay, I promise you, you will learn in this class. I will not promise you, you will get a good grade. I promise you, you will learn. Now, here we go. Go to grid view. We're ending with this. We go to grid view. We're ending with this. How many people have taken a class at JMU and gotten an A, but honestly felt like they learned nothing the entire semester? How many people have taken a whole semester? Okay, now look around, look around the grid. Okay, this is not that class. Okay, I appreciate you guys. I will grow to love you guys once I get to know you in here. You are like my academic children. Okay, I want you to be successful. As your coach, you've got to do your what?
Homework.
There we go. Let's start with that. Let's do our homework. I need you on the practice court. I need you out there practicing. I will see you on Wednesday.
Thank you.
Thank you.
Thank you, Professor.
You guys have a good day. Yes, is that Pierre?
Yes. I didn't catch your explanation of the one example, the x squared plus z squared is less than 9. Could you just explain like how that graph would look like and like how like the inequalities tells us what's going to be filled and not?
Sure, Pierre. Let me go back to where just our good friend the xy plane, because I feel like if we can land it here, we'll be able to extend it. If I had x squared plus y squared equals 9, what would that shape be? A circle. Its centers is at 0, 0, and you can kind of see, you can put it in this form. And so it's a circle, and what's the radius of that circle? What's 3? Now if I change this, Pierre, if I change that to a less than, what we learned in Algebra 2 is we test on either side of this shape. Why this test works isn't really explained, but it has a thing called convexity, but you're not ready for that. We just test. Let's pick a point inside the circle. Give me an ordered pair that falls inside this circle. 1, 1. And let's just plug 1, 1 in for x and y. When I plug 1 in, I get 1 squared for x and 1 squared for y. Is 2 less than 9? And so we then know that everybody inside here satisfies this inequality, but nobody outside the circle satisfies the inequality. Okay, and if I do less than or equal to, well, it just makes a solid line. We include the circle with everything in there. Now imagine that I've got x squared plus z squared equals 9. We're like, Dr. Warren, who's z? Well, it's another axis. If I just called the y-axis the z-axis, would it make sense the way it did with x and y? So this would be like, again, a circle of radius 3. If I do less than or equal to, we can argue that we would shade inside. Okay, now, draw yourself an XYZ. Pierre, draw yourself an XYZ. And I'm going to do the same thing. Now you're going to help me label the axes. Which axis is this? Can you see okay, Pierre, can you see okay as far as, and which axis is this? Y, and which axis is this? Z. Okay, now you're gonna help me out. Let's look at this, let's look at the y equals x. Where is that plane? Where is the y equals x plane in my drawing over here? Where's the y equals x plane in my drawing?
On the x-axis.
It's, here's the y-axis, here's the x, so it's kind of the floor, it's kind of this floor right here. Now, where's the zx plane? If you're looking over here, where would the zx plane be? Yeah, it's this plane that's kind of like right here. Do you have just a second, Pierre? Let me, because it's so much easier. Except here. So if I'm looking at this, this is like my x-axis.
Yeah.
This is my y-axis and this is my z-axis. So this is the xy plane, this flat plane right here. This is the xz plane. This plane right here is the xz plane. This is the zy plane. This is the zy plane back here. So now what we're going to do is we're going to try to draw this circle, x squared plus z squared equals 9, but over here in my zx plane. So I kind of go up 3, go out 3 here, go back 3, go down 3. Then I'm kind of drawing that circle right there. Does that make sense?
Yeah.
And again, it's solid.
Is it going like horizontally or vertically? Like,
Okay, which variable's not included here? The y. So this is where you go Dr. Strange. You can take this and sweep it in both directions, and that's where you get that cylinder laying on its side like that.
that's because like I took some notes. Like, so when y is a constant, it's on the. So when y is a constant, the points will lie on the xz plane.
They would lie on a very good pair. If y was a constant, so let's just say I go over, maybe this is 1, this is 2. If y is 2, now remember, x and z can be whatever they want now. You then get a plane that goes like this. You get a plane that runs parallel, because you can go Dr. Strange in 2 directions. You can go up and that way. And that creates a plane there. Now how about x equals 4? Where would the plane x equals 4 be? Very good, and then we would get a plane going that way as y and z do whatever they want. How about z equals 1? And then we get a plane going like that. Now let's finish with this. If I was drawing this, x squared plus y squared equals 9 is less than or equal to 9. Which variable's not there? Z. So I know I'm going to go Dr. Strange up and down. I know I'm going to go Dr. Strange up and down.
Gotcha.
And then we have a circle.
So like when the variable isn't present, like you know that like there's like a wall or something that it's running.
I'm getting chill bumps here, Pierre. I'm getting chill bumps. This is why I teach, for those moments right there where it just clicks. Because I now know you got it. I now know you got it. It's worth $1,000 to be in pay, right there.
Thank you for your explanation.
All right. Ava, how are you doing?
Good. I actually had a question about one of the homework problems.
Okay. Yeah, they can be complicated.
What?
They can be complicated.
Yeah. It was the one that you were supposed to like prove the midpoint on the line segment, and I really just didn't know how to start. Like I kind of get the idea, but I don't know how to prove it.
Yeah, that's a pretty complicated, because they actually worded it wrong. It shouldn't be proved. You're not really proving it. They want you to justify that that point would be the midpoint. That's what they want you to do, justify. Now let me try to give you a little hint for that.
Number 21.
So do you know how to get distance between 2 points in three-dimensional space?
Use the distance formula.
Yeah, very good. So let's just say I've got 2 arbitrary points in three-dimensional space. I've got a point here, and I don't know what it is, but I've got another point there. And I'm just kind of visualizing, I can't wait till you're in class. I'm visualizing one's here, and maybe one's right there. Yikes, there we go. And so there's gonna be a line segment that connects these. This would be like x1, y1, z1. And this would be x2, y2, z2. Now, could you get the distance between those 2 points if you had to? Could you come up with a formula? Now, when I say what's the midpoint between them, instinctually, where do you think the midpoint would be?
So wouldn't you like just find the distance and then divide it by 2, and that would give you the halfway point?
It would give you the halfway point, which is you could find this distance and cut it in half, and yes, but then because we haven't talked about lines, which direction, how do you know where, like, you pick it, you know this is like half of that, but you need to know the coordinates, the order triple for that point, and that's where it gets a little more complicated.
Yeah.
They want you to just justify that if you took the x coordinate of this one and the x coordinate of that one and added them together and divided by 2 and did that for all 3 of them, unbelievably, that would actually be
Oh
the
my gosh, I made this so much more complicated.
that would be the 3 coordinates. So yeah, what they want you to do is justify
Oh, okay.
that if you take the distance from here to here and the distance from there to there, it would be the same as taking twice the distance of going from there.
Okay. Yeah.
No, it's worded wrong because they should have never said proof because that's not a proof. We're just
Right.
kind of
Okay, that makes a lot more sense. Okay.
okay.
Yeah. Will this recording be up too? I already have bad sight, so I wasn't able to see a lot.
Yeah, I'm gonna put this up. My first day, I forgot being ADD.
Yeah.
I forgot to push record.
Okay.
Okay, so I'll put this up later today.
Okay, thank you so much.
All right.